It was minute 17 of the all hands when the first avatar froze. By minute 23, half the attendees had dropped back to the flat grid. By minute 31, the spatial audio had collapsed into a single muddy channel. And by minute 35, the event organizer was sending an apology message in the backup team's chat. 200 people, one custom immersive space, 0 minutes of actual team building. This is what happens when you design the experience and ignore the architecture. Most hybrid meetings are flat grids of faces where remote employees feel like outsiders looking in. The promise of immersive collaboration was supposed to fix that. Instead of tiles on a screen, you get avatars in a room. Instead of everyone talking over each other, you get spatial audio that mimics natural conversation. Instead of passive watching, you get presence. That's the sales pitch. But in reality, most immersive events create a ghost town where avatars jitter, spatial audio clips, and participants disengage faster than they do on a standard video call. The problem isn't that the 3D technology is underpowered. The problem is that organizations optimize for visual spectacle while they ignore network latency, hardware inequality, logical orchestration, and the platform's real constraints. There are 2 pillars that must be co-optimized. Latency represents the real-time performance constraints of immersive experiences. Logic represents the orchestration of workflows, identity, data, and analytics that make those experiences meaningful to a business audience. When latency and logic are in conflict, the event fails. And in 2026, with Microsoft Mesh fully absorbed into Teams, that conflict is more common than most teams realize. The research points to a clear pattern. Organizations that invest heavily in visual customization but skip network auditing experience dropout rates above 40% within the first 20 minutes. Participants on underpowered hardware report fatigue and disengagement at rates comparable to traditional video calls. And events without structured logic or fallback planning end in apology emails rather than actionable outcomes. This isn't a technology maturity problem, it's a systems engineering problem. And the organizations that treat it as such are the ones that deliver immersive team-building events that actually build teams. The research on hybrid collaboration paints a clear picture. Standard meeting platforms have made enormous progress in reliability and scale. Yet engagement metrics for long or complex sessions show attention drop-off, multitasking, and reduced participation, especially for creative or team-building activities. Participants in traditional video meetings frequently report feeling flat, transactional, and disembodied. The psychological sense of togetherness that physical co-location used to provide is largely absent. Immersive technologies were supposed to solve this by reintroducing presence. Instead of tiles on a 2-dimensional grid, participants become avatars in a shared 3D environment surrounded by spatial audio, virtual artifacts, and orchestrated activities. But the gap between that promise and the reality on the ground is where most organizations stumble. The shift to hybrid work has redefined how organizations think about presence, collaboration, and culture. Traditional all-hands meetings, off-site retreats, and team-building workshops that once depended on physical co-location have moved into virtual and hybrid formats. These events are often high stakes, not only because they involve senior leadership and large budgets, but because they're symbolic moments where culture, strategy, and trust are reinforced. When these events fail, the damage isn't just logistical, it's relational. This is the ghost town effect, and it's entirely preventable. The organizations that avoid the ghost town effect share one characteristic. They treat the event as a systems engineering problem rather than a content creation problem. They don't start with the question of what the space should look like. They start with the question of what the participants need to do, and they engineer the infrastructure, the activities, and the fallback paths to support that doing. The organizations that fall into the ghost town effect start with the visual design. They ask what the virtual headquarters should look like. They ask what 3D furniture to import, and they ask what background music creates the right mood. These are not bad questions, but they're secondary questions. The primary question is whether the network, the hardware, and the security model can support the number of participants who need to do the activities you have planned. If the answer is no, the visual design doesn't matter, because nobody will see it. The platform evolution. Mesh is dead, long live Teams, immersive. Before we fix the engineering, we need to understand what platform we're actually engineering for. Most M365 admins still think Microsoft Mesh is a separate product. It's not. Microsoft retired the standalone Mesh app in December 2025. The platform evolved into immersive spaces and immersive events inside Microsoft Teams. This isn't a rename, it's a structural consolidation. Immersive events reached general availability on December 5th, 2025. And as of April 1st, 2026, immersive events are included with Teams Enterprise at no extra cost. Previously, this required a Teams premium license. That licensing change matters because it removes the cost barrier that blocked adoption. But it also adds a support burden. IT departments now need to handle immersive traffic on standard Teams network paths without dedicated premium infrastructure guarantees. The old Mesh had its own app, its own identity flow, and its own compliance boundary. The new model inherits Teams authentication, Teams meeting scheduling, Teams compliance policies, and Teams network architecture. For organizations already standardized on Microsoft 365, this is good news. You don't need to deploy a separate platform. You don't don't need to manage separate identities. You don't need to explain to your security team why a metaverse app needs access to your corporate directory. But here is the problem. Because immersive lives inside Teams, it also inherits Teams' limitations. And those limitations are not advertised as loudly as the features. If you're planning a high-stakes hybrid event in 2026, you're not optimizing mesh. You're engineering around Teams Immersive. And most people are still using the old map. The cited benchmarks show that Teams enterprise licenses now cover up to 3,000 interactive attendees for events, with capacity packs available for larger deployments. That's a significant scale increase from earlier licensing tiers. But scale without stability is just a larger disaster. An event for 50 people with bad network planning fails quietly. An event for 500 people with bad network planning fails publicly. The useful question isn't whether immersive events are included in your license. The useful question is whether your existing Teams infrastructure can handle immersive traffic without degrading the standard meetings that run on the same network paths, because that's what is actually happening. Immersive events share the same authentication endpoints, the same media relays, and the same bandwidth profiles as your daily stand-ups and client calls. When you add 3D avatar data and spatial audio streams on top of existing video traffic, you're increasing load on infrastructure that was already sized for 2D meetings. The organizations that succeed are the ones that treat this as a capacity planning exercise. The organizations that fail are the ones that assume immersive mode is just a visual skin on top of the same Teams call. The infrastructure reality check. Let us look at what Teams Immersive actually requires. The minimum hardware for PC and Mac is a 4-core CPU and 8 GB of RAM. That's the floor, not the recommendation, the floor. Microsoft doesn't publish a minimum GPU specification. That omission matters more than it sounds, and we will come back to it in detail later. For virtual reality, Teams Immersive supports the MetaQuest 3 and MetaQuest Pro through the Microsoft Teams Immersive app. But here is the first hard edge that breaks events. Immersive events in Teams are PC and Mac first. The documentation explicitly states that immersive events are available on PC and Mac and that Quest support is coming soon. This creates a critical ambiguity. The Metastore page lists Quest 3 and Quest Pro as supported. The Microsoft Learn Planning page says Quest isn't yet supported for immersive events. If you're building an event strategy that depends on VR headsets, you need to verify the current client support matrix before you send a single invite. This ambiguity isn't a footnote, it's a potential showstopper. If you invite 50 participants and 10 of them plan to join on Quest devices, but Quest isn't supported for immersive events on the day, those 10 participants can't attend. There's no 2D fallback inside an immersive event. They're simply locked out. What isn't supported is just as important as what is. Teams Immersive doesn't work on web browsers. It doesn't work on mobile devices. It doesn't work in VDI environments. It doesn't work on Microsoft Teams rooms. It doesn't support dial-in. It isn't available in GCC, GCCH, sovereign clouds, or EDU environments. That's a long list of exclusions. And every one of them is a participant who will show up to your event and discover they can't join. Let us look at each exclusion and what it means in practice. No web support means that participants who typically join Teams meetings from a browser can't participate. In many organizations, external partners and contractors use browser-based Teams access because they don't have the desktop app installed. Those users are excluded. No mobile support means that anyone on a phone or tablet is out. For hybrid events where some participants are traveling or away from their desk, this is a significant constraint. No VDI support means virtual desktop environments like Citrix or Windows 365 can't render the 3D client. Organizations with heavy VDI usage for security or remote work need to provide separate physical devices for immersive event participation. No Teams Rooms support means that conference rooms equipped with Teams Rooms devices can't join immersive events. If you plan to have in-room participants gather around a Teams Room screen and join the immersive space together, that plan doesn't work. No dial-in means there's no phone bridge for users with unreliable internet. In a standard Teams meeting, dial-in provides a critical fallback. In immersive mode, it doesn't exist. And the GCC, GCCH, sovereign cloud, and EDU exclusions mean that government contractors, defense organizations, educational institutions, and certain international entities can't use immersive events at all. Guest users can attend immersive events, but they can't be organizers or co-organizers. External cross-tenant users and anonymous users are completely blocked. If your team-building event includes vendors, partners, or candidates who don't have accounts in your tenant, they need to be added as guests in advance. And even then, guest users can't join immersive events on Quest devices. This is the first layer of reality. Before you design a single 3D object or choose a virtual background, you need to know who can actually get in the door. The organizations that skip this check are the ones that discover exclusion problems when the event is already live. The network architecture. What immersive traffic actually looks like. Once you know who can join, you need to know what the traffic looks like. Teams Immersive builds on top of standard Microsoft Teams network requirements. It uses the same authentication endpoints, the same identity flows, and the same media transport paths. But it adds extra bandwidth for immersive capabilities like avatar movement and spatial audio. Per participant, the bandwidth requirements break down like this. The minimum is 30 kilobits per second upstream and 370 kilobits per second downstream. The recommended is 80 upstream and 700 downstream. The best performance target is 100 upstream and 850 downstream. Those numbers are for immersive participation alone. When someone shares their screen, the profile changes dramatically. With screen sharing active, the minimum jumps to 440 kilobits per second downstream and 830 upstream. The maximum can spike to 8,176 kilobits per second downstream and 8,926 upstream. That's nearly 9 megabits per second for a single participant with screen sharing. If you have 20 participants in a custom space and 2 of them are presenting, your network edge needs to handle immersive avatar data plus high bandwidth screen share streams simultaneously. Most enterprise networks can absorb that load in the aggregate. The problem is rarely total bandwidth. The problem is latency, jitter, and routing. Teams Immersive requires standard Microsoft 365 endpoints plus the IP addresses and port ranges detailed in the Azure Communication Services network requirements. Without access to those endpoints, media capabilities like audio and screen sharing fail. If your organization routes all traffic through a central VPN concentrator before it exits to the internet, you're backhauling real-time media through an extra hop. That extra hop adds latency. It adds jitter, and it turns a smooth, immersive experience into a stuttering mess. The weird part is that many organizations already solved this for standard Teams video calls. They implemented split tunneling years ago. They configured local internet breakout. They optimized media paths. But they forget that immersive events use the same infrastructure. They assume that because standard video calls work fine, immersive mode will work fine too. That assumption is broken. Immersive mode adds avatar state synchronization, spatial audio streams, and 3D environment data on top of the existing video and audio traffic. The bandwidth multipliers we discussed earlier are not theoretical maximums. They're real numbers that your network needs to handle per participant. Split tunneling isn't optional for immersive events. It's essential. Your firewall needs to allow traffic to cloud. Microsoft.com, Office.com, GraphMicrosoft.com, Substrate.office.com, and Microsoft.com over TCP 443 and 80, and it needs the Azure Communication Services ranges for the media path. If your network team treats Teams traffic like generic web traffic, your immersive event will degrade silently. Participants won't see a clear error message. They will just float in a laggy space while their avatars move 2 seconds behind their input. That isn't a bug they can report, it's a network architecture problem that you need to solve before the event starts. The network path also matters for guest users. If your guest users join from home networks, they're outside your corporate firewall and outside your WAN optimization. Their traffic routes directly to Azure over consumer internet connections. And those connections vary dramatically in quality. A guest user on fiber broadband in a major city may have better network performance than an employee on corporate Wi-Fi in a rural office. That inversion is counterintuitive for IT teams who assume that corporate networks are always better than consumer networks. But for cloud-hosted services, the direct internet path is often faster than a path that routes through corporate infrastructure. The practical implication is that you can't optimize the guest experience from your side. You can only set expectations. Tell guest users to join from a stable wired connection rather than Wi-Fi. Tell them to close unnecessary applications. And tell them to test their connection using the same test link you provide to employees. The guest user experience is also affected by conditional access policies. Even if a guest user has a perfect network connection, they may be blocked by a conditional access policy that requires device compliance or multi-factor authentication. Guest users are typically on unmanaged devices, and unmanaged devices often fail conditional access checks. The organizations that handle guest access well create a dedicated conditional access policy for immersive event guests. They relax device compliance requirements while maintaining identity verification. They test the guest sign-in flow with a personal device before the live event. And they have a support contact ready to help guests who encounter access issues. The organizations that ignore guest access assume that guest users will figure it out. And they discover during the event that half their external participants can't get past the sign-in screen. The organizations that get this right run a network audit 2 weeks before any immersive event. They test the path from every office location that will participate. They verify jitter levels during peak hours. And they confirm that their firewall rules match the current Azure Communication Services IP ranges, which Microsoft updates periodically. The organizations that get this wrong assume the network is fine because standard Teams meetings work. And they learn the hard way that immersive traffic isn't standard Teams traffic. There's a specific network optimization that many organizations overlook. Quality of service markings. QoS is a mechanism that tags network traffic with priority levels. Real-time media like voice and video get high priority. File downloads get low priority. And generic web traffic gets best effort treatment. For immersive events, QoS is critical because the traffic mix is more complex than a standard Teams call. A standard Teams call has 2 primary streams, audio and video. An immersive event has audio, video, avatar state data, spatial audio metadata, and environment synchronization data. Some of these streams are more latency sensitive than others. Avatar state data needs to arrive quickly to maintain the illusion of co-presence. But it can tolerate occasional loss because the client can interpolate between known positions. Audio data can't tolerate loss because gaps in audio are immediately noticeable. And environment data, like texture loading and object placement, is less time-sensitive but more bandwidth-intensive. A well-configured network applies different QoS policies to each stream type. Audio gets the highest priority. Avatar state gets second priority. Environment data gets third priority, and non-critical traffic like background file sync gets lowest priority. If your network applies a single QoS policy to all teams' traffic, the bandwidth-heavy environment data can crowd out the latency-sensitive avatar state. The result is smooth visuals with jerky avatar movement, or clear audio with delayed spatial positioning. The fix is to work with your network team to implement application-aware QoS policies. Microsoft publishes detailed guidance on QoS markings for Teams media traffic, and the same markings should be extended to immersive event traffic. This requires cooperation between the event organizer, the IT department, and the network operations team. And that cooperation is exactly what separates organizations that succeed from organizations that struggle. Latency budgets and human perception. Bandwidth is only half the story. The other half is what happens to time. In immersive environments, there are three distinct forms of latency that matter. Motion-to-photon latency is the delay between a user moving their head and the visual scene updating on their display. Audio latency affects the perceived synchronization of speech and spatial audio cues. Interaction latency relates to how quickly actions like grabbing an object or triggering an animation are reflected to the user and to other participants. For VR and mixed reality, motion-to-photon latency is particularly critical. Many experts consider total motion-to-photon latencies above roughly 20 milliseconds to be potentially noticeable. At higher levels, discomfort sets in. But Teams Immersive isn't primarily a VR platform. It's a desktop-first experience with VR as an optional endpoint. That changes the entire latency equation. Desktop users don't experience motion-to-photon latency in the same way because they're not rotating their head against an inertial reference frame. Their latency challenge is interaction lag and avatar synchronization. When one participant moves and another sees that movement delayed by 100 milliseconds or more, the sense of shared presence breaks down. The cited benchmarks show approximate tolerances for different collaboration modes. Text chat tolerates several seconds of latency latency because it's buffered and asynchronous. Standard video conferencing audio tolerates up to 150 to 250 milliseconds before turn-taking feels awkward. Casual 3D collaboration with avatars and objects tolerates 100 to 200 milliseconds. High immersion VR locomotion demands 20 to 50 milliseconds motion to photon for comfort. Fast-paced game-like interactions need 50 to 100 milliseconds for competitive fairness. Teams Immersive sits in an interesting middle ground. Because the primary client is desktop, the motion-to-photon demands are relaxed. But because the platform supports Quest headsets for users who want deeper immersion, the same event must simultaneously satisfy desktop latency budgets and VR latency budgets. That's a hard dual constraint. Audio latency is more forgiving but still important for natural conversation. Latencies under about 150 to 200 milliseconds are generally considered acceptable before turn-taking feels awkward. In spatial audio environments where direction cues matter, lower latencies are beneficial. If a voice sounds like it's coming from the left but the avatar is on the right, the brain registers a mismatch. That mismatch is subtle, but it accumulates. The real killer isn't stable latency. It's jitter. Users tolerate slightly delayed feedback if it's predictable. They don't tolerate unpredictable jumps. In immersive environments, jitter causes avatars to snap between positions. It causes audio to stutter. And it destroys the sense that you're sharing a coherent space with other people. Think of it this way. A highway with a steady speed limit of 50 miles per hour is predictable. A highway where the speed limit changes every 10 seconds is exhausting. Jitter is the second highway. For high-stakes events, you need to think in terms of latency budgets. A latency budget allocates the total acceptable delay among rendering, networking, processing, and encoding. If you set a maximum acceptable interaction latency at 100 milliseconds, you might conceptually allocate 20 milliseconds for client-side processing, 40 milliseconds for network round-trip, and 40 milliseconds for server-side update and synchronization. In practice, Microsoft manages many of these concerns automatically. The mesh service handles session management, spatial synchronization, and state replication in the cloud. Clients locally predict motion to keep the experience responsive. The server reconciles authoritative state across all connected participants, but event planners and IT engineers can still influence network path optimization, local device performance, and client modality choices. A participant on an older laptop with an overloaded CPU may experience local rendering bottlenecks that hurt perceived latency even if the network is fine. A participant connecting through a high-latency VPN tunnel may be disadvantaged in fast-paced interactions compared to someone on a direct internet connection. The human perception layer adds another nuance. Users are more tolerant of latency when visual feedback is continuous, even if slightly delayed. They're less tolerant when latency is inconsistent. That's why jitter is often more disruptive than a slightly higher but stable latency. In immersive environments, unpredictable jumps in avatar positions or delayed state updates break trust. And once trust is broken, presence is gone. The useful question for event planners isn't whether your average latency is low, it's whether your worst-case jitter stays within the tolerance window for the activities you planned. If you're running a collaborative puzzle, 200 milliseconds of stable latency is fine. If you're running a reaction time competition, 50 milliseconds of jitter can make the activity feel rigged. Design your activities around your network reality, not around your ideal network. There's another latency factor that's rarely discussed in event planning guides: server load during peak hours. Microsoft Teams Immersive runs on Azure infrastructure. That infrastructure is massively scalable, but it's also shared. Your immersive event isn't running on a dedicated server reserved for your organization. It's running on a shared pool of compute resources that serve thousands of other customers simultaneously. For most use cases, this isn't a problem. Azure's load balancing handles traffic spikes gracefully, but during major product launches, global conferences, or seasonal peaks, the shared infrastructure experiences higher load. And that higher load can increase server-side processing latency. Server-side response times for cloud-hosted services typically vary between off-peak and peak hours. For a latency-sensitive immersive event, that variation matters. An event scheduled at 9 a.m. Pacific time may experience different server performance than an event scheduled at 2 p.m. Pacific time. You can't control Microsoft's server load, but you can schedule around it. Avoid scheduling immersive events during major Microsoft product announcements, global keynote streams, or known peak usage windows. And if you're running a critical event, schedule it during off-peak hours for your primary Azure region. The other server-side consideration is geographic distribution. If your participants are spread across multiple continents, their traffic routes to different Azure data centers, a participant in Sydney connects to an Azure region in Australia, a participant in Frankfurt connects to an Azure region in Europe, and a participant in New York connects to an Azure region in the United States. Microsoft's infrastructure synchronizes state across these regions, but the synchronization itself adds latency. A participant in Sydney sees the avatar movement of a participant in New York after the trans-Pacific round trip. That round trip is typically 150 to 200 milliseconds. For conversation and collaborative activities, that delay is acceptable. For competitive activities that require tight synchronization, it's a structural disadvantage. If your event includes participants from multiple continents, design activities that are asynchronous or turn-based rather than synchronous and competitive. The organizations that handle global distribution well create region-specific sub-events rather than one massive global event. They run the same agenda in 3 time zones with 20 participants each rather than 60 participants in one session. That approach reduces server load, minimizes inter-region latency, and improves the experience for everyone. The hardware parity trap. Here is the latency trap that most organizers miss entirely. It's hardware parity. Hybrid team building events bring together participants with wildly different technical setups. Some join from high-performance PCs on corporate networks. Others join from constrained consumer devices over variable home connections. Some use VR headsets. Many still join from traditional 2D clients, though immersive events don't support 2D fallback within the same meeting. That last point needs emphasis, so let me pause here. If you schedule an immersive event, participants must join in immersive mode. There's no 2D fallback inside the same event. If a participant can't run the immersive client, they can't attend. This is fundamentally different from a standard Teams meeting where someone on mobile can still participate fully. That exclusion is the first parity problem. The second is the experience gap between desktop and VR users. Quest users get head-tracked 3D perspective, 6 degrees of freedom movement, and hand presence. Desktop users get a third-person camera and keyboard and mouse navigation. These are not equivalent experiences. If VR participants are given significantly richer interactions than desktop participants, the event can inadvertently reinforce hierarchy or exclusion. The person in the headset feels like they're really there. The person on the laptop feels like they're playing a video game. If you constrain the experience to the lowest common denominator, the promise of immersion dies. If you let the gap widen, you fragment the team. There's also a competitive fairness issue. When events involve reaction time or rapid decision-making, participants with lower latency connections or more powerful devices gain a structural advantage. They see updates first, they trigger interactions faster, and they win team challenges because of technical edge rather than skill or engagement. That advantage is invisible to the facilitator. It isn't visible in the event report, but the participants feel it, and it subtly undermines the exact team cohesion you're trying to build. The research points to a clear mitigation strategy. Favor activities that depend on collaboration, creativity, and problem-solving rather than reaction time competition. Where competitive activities are necessary, use server-mediated resolution that doesn't depend on sub-100 millisecond timing. Turn-based mechanics, collaborative puzzles, and creative challenges neutralize latency asymmetries because the server has time to reconcile state across all clients. Be transparent with participants about connectivity differences, and build a culture that values participation over winning. The goal of a team-building event isn't to crown a champion, it's to create shared experience. The organizations that handle this well run a hardware pre-check 1 week before the event. They ask participants to confirm their device type, they identify anyone on unsupported hardware and provide alternatives, and they design activities that work equally well on Quest and desktop so that device choice doesn't determine engagement quality. The organizations that handle this poorly assume that everyone has the same setup, and they discover during the event that half their team is navigating with a keyboard while the other half is physically walking around a virtual room. That disparity isn't a minor UX difference, it's a structural inequality that shapes who participates and who withdraws. The experience gap also manifests in navigation confidence. Quest users physically turn their heads and walk around the space. The movement is intuitive because it maps to real-world spatial reasoning. Desktop users press arrow keys or click waypoints. The movement is abstract because it requires translating 2D input into 3D movement. This navigation difference affects who explores the space and who stays near their spawn point. In most immersive events, desktop users cluster near entry points while VR users explore the full environment. The desktop users miss hidden features, side rooms, and optional content because they don't know how to reach them. And the VR users feel like the space is underutilized because half the participants never leave the central plaza. The fix is to design environments that are intentionally simple for desktop navigation. Wide corridors rather than narrow passages, elevated platforms with ramps rather than stairs, and obvious visual cues that guide keyboard users toward key locations. If an important interaction zone is tucked behind a corner, desktop users will miss it. If it's visible from the main path, everyone will find it. The other fix is to assign mixed device teams deliberately. Pair a Quest user with a desktop user in the same team. The Quest user can navigate quickly and describe what they see. The desktop user can manage shared documents and chat communication. Each participant contributes based on their device's strengths, and neither feels like they're carrying the other. This mixed device pairing also creates a natural mentoring dynamic. The Quest user teaches the desktop user how to navigate. The desktop user teaches the Quest user how to access shared files. And the cross-device collaboration becomes a team-building activity in itself. The organizations that handle hardware parity well don't try to eliminate the device gap. They design around it. They create roles for each device type. They pair participants across device types. And they measure success by team collaboration rather than individual achievement. Spatial audio, engineering presence through sound. If latency is the invisible architecture of immersive events, spatial audio is the hidden engineering of presence. Teams Immersive uses spatial audio to enable multiple small group discussions in the same virtual space. Directionality and distance mimic natural human conversation circles. When two avatars stand close together, they hear each other clearly. When someone walks away, their voice fades with distance. This isn't a gimmick, it's a structural feature that reintroduces the social physics of physical space. In a standard Teams meeting, everyone hears everyone at the same volume. That creates the cocktail party problem. If 20 people are talking, you can't focus on any one conversation. Spatial audio solves this by letting you move toward the conversation you want to join and away from the ones you do not. But spatial audio only works when the timing is right. Audio latency under 150 to 200 milliseconds is acceptable for conversation. In spatial audio, the added constraint is lip sync and directionality alignment. If a voice arrives slightly late but from the correct direction, the brain is fairly forgiving. If the voice arrives from the wrong direction, the mismatch is immediate and disorienting. Poor spatial audio mapping creates what I call the ghost voice effect. Someone sounds like they're standing right next to you, but their avatar is across the room, or their voice fades as you approach them. These are not rare glitches. They are the predictable result of misconfigured audio emitters or overloaded clients dropping spatial processing. Strategic placement of audio zones matters. You want interaction zones where conversation naturally clusters. You want quiet zones where people can step away without leaving the event. And you want transition zones where the audio fades smoothly rather than cutting abruptly. Microsoft handles much of this automatically in the out-of-the-box environments. But if you're customizing a space, you need to think about audio as architecture, not as a feature you toggle on. The most common mistake is creating a beautiful virtual auditorium and then discovering that the stage audio bleeds into every corner of the room. Participants in the back row hear the presenter as if they're standing on stage. There's no spatial separation. And without spatial separation, you might as well be on a flat grid. Sound is the hidden architecture of presence. Get it wrong, and the space feels hollow even when it looks stunning. The research on spatial audio in mixed reality environments is clear. Spatial sound increases user confidence in UI interactions and immerses users in the experience when it's properly implemented. But the implementation details matter enormously. Audio emitters need to be positioned at the correct height relative to avatars. Reflection and occlusion parameters need to match the virtual environment's geometry. And the volume fall-off curve needs to feel natural to human ears. Most out-of-the-box Teams immersive environments handle these parameters reasonably well. But when organizers add custom media objects, they sometimes place audio sources at the origin point of the 3D model rather than at the logical emission point. The result is a video screen that sounds like it's broadcasting from the floor, or a presenter whose voice seems to come from behind them rather than from their mouth. These are small errors that have a large perceptual impact. The brain is finely tuned to detect inconsistencies between visual and auditory cues. When the eyes see a person speaking, but the ears hear the voice from the wrong location, the brain flags the environment as artificial. That flagging breaks immersion far more effectively than low-resolution textures or simple avatar models. The spatial audio implementation in Teams Immersive also has platform-specific constraints. On desktop clients, spatial audio is rendered through standard stereo headphones or speakers using head-related transfer function processing. On Quest devices, spatial audio uses the headset's built-in audio pipeline with head-tracked binaural rendering. These two paths produce different perceptual results. A desktop user with laptop speakers may hear spatial audio as simple left-right panning. A Quest user with sealed headphones may hear full three-dimensional positioning, including elevation cues. That difference matters for event design. If your activity depends on participants locating each other by sound alone, Quest users will have a significant advantage over desktop users. If your debrief involves a presenter speaking from a stage, desktop users may struggle to locate the sound source in a way that Quest users do not. The practical response is to design for the lowest common denominator while providing optional enrichment for VR users. Ensure that all critical audio information is also available visually. Use on-screen labels, directional arrows, or visual highlighting to reinforce spatial audio cues. And avoid activities where success depends on precise audio localization, because the localization accuracy varies dramatically between device types. Get it right, and something interesting happens. Participants start behaving like they're in a real room. They move toward people they want to talk to. They step away from loud groups. They gather in corners for side conversations. All of this happens naturally when spatial audio is configured well. None of it happens when the audio is flat. The practical guidance is to test your spatial audio with a pilot group before the live event. Place 4 participants in different corners of the space. Have 2 of them talk while the other 2 listen from a distance. Verify that the distant pair can barely hear the conversation. Then have them walk closer and confirm that the volume increases naturally. If the audio jumps from silent to loud at a specific boundary, your spatial mapping is too coarse. If everyone hears everything regardless of distance, your spatial audio isn't working at all. This test takes 10 minutes. And it reveals more about your event quality than any amount of visual customization. The GPU and rendering bottleneck. There's another latency problem that lives on the device itself, and Microsoft doesn't talk about it enough. The minimum hardware specification for Teams Immersive is a 4-core CPU and 8 GB of RAM. There's no published minimum GPU requirement. That omission is a blind spot. Rendering a 3D environment with multiple avatars, spatial audio processing, and screen sharing is GPU intensive. An older laptop with integrated graphics may technically meet the CPU and RAM floor while failing catastrophically at the rendering layer. When the GPU is overloaded, frame rates drop, and frame rate drops create perceived latency. The avatar moves, the network delivers the update on time, but the screen stutters. So the user perceives lag even when the latency budget is technically within spec. There's no official benchmark published by Microsoft for Teams immersive frame rates, but you can run a simple pre-event diagnostic. If a device can't smoothly handle a 720p Teams video call with multiple participants, it will struggle with immersive mode. Open Windows Task Manager or macOS Activity Monitor during a standard Teams call. If the GPU is already above 70% utilization, immersive mode will push it over the edge. This is why hardware audits matter more than bandwidth audits in some organizations. A corporate office with gigabit fiber and 10-year-old laptops will have a worse immersive experience than a home office with modern hardware and average broadband. The rendering bottleneck also affects thermal throttling. Laptops on battery power often reduce GPU performance to conserve energy. A device that runs immersive mode fine while plugged in may drop frames after 20 minutes on battery. If your event lasts an hour, that thermal profile matters. Battery life is another under-discussed factor. Rendering 3D environments consumes significantly more power than standard video calls. A laptop that lasts 4 hours in a Teams meeting may drain in 90 minutes during immersive mode. If your event is 60 minutes plus setup and debrief time, participants on battery may see their device shut down before the closing remarks. The practical advice is this: test every device class that will join your event. Don't assume that meeting the published CPU and RAM spec is sufficient. Don't assume that corporate hardware is better than consumer hardware. And don't assume that devices perform the same on battery as they do on AC power. Microsoft's hardware minimum is a starting point. It isn't a guarantee. The organizations that prepare well send a hardware checklist to participants 1 week before the event. They recommend AC power. They recommend closing unnecessary applications. And they provide a test link so participants can verify their setup before the live event. The organizations that skip this step find out during the first activity that half the laptops are stuttering, and by then, there's no quick fix. Another common hardware issue is audio output configuration. Teams Immersive relies on spatial audio to create the sense of presence, but spatial audio requires stereo output. If a participant's laptop is configured for mono output, or if they're using a single Bluetooth earbud, the spatial audio effect is completely lost. This is a subtle failure mode. The participant hears audio, they can understand speech, but they can't locate sound sources in the 3D space. And that inability breaks the spatial experience without the participant knowing why. The pre-event checklist should include an audio test. Ask participants to verify that their audio output is stereo, ask them to test with headphones rather than laptop speakers, and ask them to confirm that their Bluetooth connection is stable, because Bluetooth audio adds its own latency layer that can degrade the spatial audio timing. The pre-event checklist should also address display configuration. Immersive mode renders in 3D perspective. A small laptop screen makes navigation difficult because the field of view is narrow. An external monitor improves the experience significantly. And a dual monitor setup can actually degrade the experience if the immersive window spans both displays with different resolutions. The practical guidance is to recommend a single display of at least 15 inches for desktop participants, and to recommend that Quest users verify their Guardian boundary is set up before the event starts. A participant who discovers their Guardian boundary is too small in the middle of the event will need to pause, recalibrate, and rejoin. That disruption affects not just the individual but the team they're participating with. There's also a memory pressure factor that's rarely discussed. Immersive mode loads 3D assets, avatar textures, spatial audio buffers, and environment geometry into system memory. A device with 8 GB of RAM may technically meet the minimum spec, but if 3 GB are already consumed by the operating system, browser tabs, antivirus software, and background applications, the remaining memory may be insufficient for a complex custom environment. When memory is exhausted, the operating system begins paging to disk. On a laptop with a spinning hard drive, this creates multi-second freezes. On a laptop with a solid-state drive, the freezes are shorter but still noticeable. And in an immersive environment, even a half-second freeze breaks the sense of continuous presence. The memory pressure is worse on devices that use integrated graphics because integrated GPUs share system memory rather than having dedicated video RAM. A device with 8 GB of total RAM and integrated graphics may have only 4 GB available for the operating system and applications after the GPU reservation. That's below the effective minimum for a comfortable immersive experience. The practical guidance is to recommend 16 GB of RAM for any device that will run immersive mode regularly, and to recommend a discrete GPU with at least 4 GB of video memory for organizers and facilitators who need to run screen sharing and 3D rendering simultaneously. These are not Microsoft-published requirements. They're field-tested recommendations based on the actual performance profile of the application. The pattern interrupt, a story of failure. Think back to the event I described at the start, the one where the avatar froze at minute 17 and half the attendees had dropped by minute 23. Let me tell you exactly why it fell apart. This isn't a fictional scenario. It's the predictable outcome of treating an immersive event like a Teams meeting with extra steps. Let me tell you what went wrong. The organization had spent weeks designing a custom virtual headquarters. They imported their logo, placed 3D furniture, and recorded welcome videos. They sent branded calendar invites and told everyone to join via Teams immersive mode. They did not check who could actually access it. They did not realize that 40% of their workforce typically joined meetings via mobile or web. Both are unsupported for immersive events, so those participants simply couldn't attend. They did not test the network path. Their corporate VPN backhauled all traffic through a data center 200 miles from the nearest Azure region. The added round-trip time pushed jitter above acceptable thresholds for real-time avatar synchronization. They did not audit hardware. Half the laptops in the organization were 5-year-old models with integrated graphics that couldn't maintain stable frame rates in 3D mode. Those users experienced stuttering avatars and delayed audio. They did not configure spatial audio zones. The entire space used a single global audio channel, so 60 avatars in one room created a wall of noise where nobody could distinguish who was speaking. And they had no fallback plan. When immersive mode failed, there was no backup structure, no standard Teams meeting link ready, no facilitator script for pivoting to a different format. The result was a demoralized team, a wasted budget, and an executive who concluded that immersive collaboration doesn't work. The aftermath was worse than the event itself. The organization had invested in a culture initiative that was supposed to rebuild connection after a difficult quarter. Instead, it reinforced the belief that remote employees are second-class participants. The people who couldn't join because they were on mobile or web felt excluded. The people who joined but experienced stuttering and audio dropouts felt that the company had not invested in their experience. And the people who had a relatively smooth experience felt guilty that their colleagues had suffered. None of these outcomes were visible in the post-event survey because most participants did not complete it. The completion rate was 22%. Of those who completed it, 70% rated the event as poor or very poor. The open text responses mentioned technical issues more often than content issues. The executive summary that went to leadership said the event failed because the technology was not ready. But the technology was ready. The platform was capable of hosting a successful event. What failed was the preparation. The pattern is common. An organization hears about immersive collaboration. They see a demo video with smooth avatars and beautiful environments. They assume that the platform will handle the hard parts automatically. And they invest their energy in visual customization while ignoring the infrastructure underneath. The video they saw was produced by a team that tested the environment with 5 people on the same network. Their event had 200 people on 6 continents. The demo video had no screen sharing, no guest users, and no conditional access policies. Their event had all 3. But immersive collaboration does work. It just requires engineering, not marketing, not design, but real engineering. And the organizations that approach it with that mindset build events that people remember for the right reasons. The difference between a failed immersive event and a successful one is rarely the budget. It's rarely the creativity of the environment design. It's the thoroughness of the engineering checklist. Organizations that run successful events spend more time in preparation than in customization. They test failure modes. They verify access for every participant class. They measure network paths. And they build fallback plans that they never need to use. That preparation is invisible to the participants. And that's the goal. The best immersive event feels effortless to the people who add. What logic means in immersive events? We have covered the latency pillar. Now we move to the logic pillar. Logic is everything that happens behind the scenes to coordinate and manage the event. It ranges from simple sequences to complex conditional flows driven by participant actions. A simple sequence looks like this. At minute 10, display the first challenge instructions. At minute 15, unlock the second zone. At minute 30, bring everyone back to the main auditorium for debrief. A complex flow looks like this. If Team A completes the puzzle before Team B, unlock a bonus zone for Team A and update the live leaderboard. If nobody completes the puzzle within 20 minutes, trigger a hint broadcast to all teams. If a participant disconnects and rejoins, restore them to their assigned team zone with their previous progress intact. Logic also includes integration with the rest of Microsoft 365. A Power Automate flow might listen for a team completion event and then update a SharePoint leaderboard. It might send a notification to a Teams channel. It might grant a digital badge through Viva. Mesh provides the spatial presence and synchronization. Microsoft 365 and Power Platform provide the logic, data, and integration necessary to turn events into repeatable programs. Without that logic layer, every immersive event is a one-off stunt. You build it, you run it, you manually export the feedback, and you start from scratch next quarter. With the logic layer, you get registration through Power Apps, team assignment through Dataverse, event orchestration through Power Automate, and reporting through Power BI. The immersive space becomes the front end of a broader system, and that system is what makes the event scalable, measurable, and repeatable. The challenge is that logic must remain coherent and resilient even when network conditions, client reliability, and human behavior are unpredictable. Unlike traditional web forms or line-of-business apps, immersive events are dynamic, multi-user, and temporally constrained. If logic fails in the middle of a live session, there's limited opportunity for recovery without breaking immersion. That's why the logic layer needs fallback paths, and we will get to those. For now, the key insight is this. Most organizations invest 90% of their effort in visual customization and 10% in logical orchestration. The successful ones flip that ratio. They spend more time designing the flow of the event than decorating the space, because participants remember what they did, not what the walls looked like. Let us look at what the logic layer actually looks like in practice. For a typical team-building event, the logic layer has 4 components. Pre-event logic handles registration, team assignment, and environment setup. Event logic handles timing, state transitions, scoring, and participant tracking. Integration logic connects the immersive event to the rest of the Microsoft 365 ecosystem. And post-event logic handles feedback collection, reporting, and follow-up actions. Pre-event logic often starts in Power Apps. You build a registration form that captures participant name, department, dietary restrictions, if the event includes a physical component, and device type. That data writes to a Dataverse table. From there, a Power Automate flow assigns participants to teams using a round-robin algorithm or a department mixing rule. The flow then generates calendar invites with the immersive event link and a pre-event hardware checklist. The pre-event checklist is itself a logic artifact. It should include device verification steps. It should include a test link to the immersive space. And it should include clear instructions about unsupported platforms. If a participant discovers they can't join on their primary device, they need time to find an alternative. Sending this checklist 48 hours before the event is too late for people who need to borrow a laptop or visit the office. Send it 1 week before. Event logic is where the real-time orchestration happens. At its simplest, this is a facilitator with a stopwatch and a script. At its most complex, it's a set of Power Automate flows triggered by event milestones. For example, when the last team completes the icebreaker activity, a flow might unlock the main challenge zone and broadcast a message to all participants. When the main challenge timer expires, another flow might aggregate scores from a SharePoint list and generate a leaderboard display. The challenge with real-time event logic is that Power Automate flows have execution delays. A flow triggered by a SharePoint list update may take 30 to 60 seconds to run. In a fast-paced event, that delay is noticeable. For time-sensitive transitions, a human facilitator with manual controls is often more reliable than an automated flow. The best approach is a hybrid. Use Power Automate for pre-event setup and post-event aggregation. Use manual facilitator controls for real-time transitions during the event. And use Dataverse or SharePoint lists as the single source of truth for team assignments, scores, and progress tracking. Integration logic connects the immersive event to the broader Microsoft 365 ecosystem. This is where the value of the Teams immersive platform becomes clear. Because the event is a Teams meeting, it inherits all standard Teams capabilities. Meeting chat is available for text-based side conversations. Meeting recordings can capture the facilitator's perspective for participants who couldn't attend. And meeting attendance reports provide basic participation data, but the integration goes deeper. SharePoint can host the custom media files, 3D models, and documents referenced in the environment. OneDrive can store participant-generated content like screenshots or shared notes. Power BI can visualize engagement metrics against historical baselines. And Viva Insights can correlate event participation with broader employee experience signals. The research on this integration points to a clear best practice. Organizations that treat immersive events as isolated experiences get one-off value. Organizations that treat them as part of a continuous employee engagement program get compounding value. The difference is integration. When event data flows into the same dashboards that track meeting quality, learning completion, and collaboration patterns, leadership can see immersive events as part of the productivity picture rather than a separate line item. Post-event logic is where most organizations drop the ball. They run the event, they collect some verbal feedback, and they move on to the next initiative. The successful organizations send a structured survey within 2 hours of the event ending. They aggregate responses in Power BI, they review technical issues with the IT team, and they document lessons learned in a shared knowledge base. That documentation becomes the foundation for the next event, and over time the organization builds an institutional memory of what works, what fails, and how to prevent the failures. For now, the key insight is this. Most organizations invest 90% of their effort in visual customization and 10% in logical orchestration. The successful ones flip that ratio. They spend more time designing the flow of the event than decorating the space, because participants remember what they did, not what the walls looked like. State, consistency, and the multi-user problem. One of the most important concepts in distributed systems is the distinction between strong consistency and eventual consistency. In a strongly consistent system, every client sees the same state at the same time after any update. In an eventually consistent system, different clients may temporarily see different states, but their views converge over time. Teams Immersive, like all multi-user spatial platforms, balances consistency and latency to maintain comfort and responsiveness. Each client may locally predict certain aspects of motion to avoid visual lag. The server coordinates authoritative state to reconcile differences. This can lead to situations where a user briefly sees an object in a slightly different position than another user sees it, or where two users attempt the same interaction nearly simultaneously and the system must decide whose action wins. In casual collaboration, these minor inconsistencies are tolerable. In structured team-building activities with scoring and win conditions, they matter a lot. Imagine two participants racing to press a virtual button. Both press it within 50 milliseconds of each other. Client A shows that participant A won. Client B shows that participant B won. For a moment, there are two competing truths. The server eventually reconciles this and declares one winner. But during that reconciliation window, the clients are out of sync. If the game logic runs client side, you can get irreversible conflicts. Client A awards points to participant A. Client B awards points to participant B. Both clients sent their scoring updates to the server. Now the server has two conflicting scores and no clean way to resolve them. The design principle is simple. Keep the client responsive for movement and visual feedback, but treat the server as the source of truth for durable state. Critical state changes like scoring, puzzle completion, and zone unlocking should be mediated by server-side logic that applies deterministic rules. For event designers, this means choosing game mechanics that are robust to small inconsistencies. Turn-based interactions eliminate race conditions entirely. Collaborative puzzles, where the whole team contributes to a shared progress bar, are more resilient than competitive speed challenges. And any activity that depends on precise timing should include a server-side cooldown or lockout mechanism. The other practical implication is testing. You can't test multi-user race conditions with one person. You need at least 3 or 4 participants in a pilot session, all attempting the same interactions from different network conditions. That's the only way to discover whether your game logic handles server reconciliation gracefully. Most organizations skip this test. They customize the environment with one account, they verify that the objects look right, and they assume the interactions will work the same way with 50 people. That assumption is broken. The research on distributed systems is clear. State conflicts increase exponentially with participant count and network variability. An interaction that works perfectly in a pilot with 2 people on the same network may fail reliably with 20 people on different continents. There's a specific failure mode that deserves attention: the thundering herd problem. When a facilitator unlocks a new zone or reveals a challenge, all participants typically rush toward it simultaneously. In a standard web application, this would be handled by load balancing and request queuing. In an immersive environment, the thundering herd creates a sudden spike in avatar density, spatial audio load, and object interaction requests. If the server infrastructure isn't prepared for that spike, some participants see the new zone before others, some participants hear the announcement audio clearly while others hear garbled fragments. And some participants find that the interactive objects in the new zone are unresponsive because the server is overloaded processing state updates from the initial rush. The fix is to stagger access. Instead of unlocking a zone for everyone at once, unlock it for teams in sequence. Team A gets access at minute 15, Team B gets access at minute 16, Team C gets access at minute 17. This staggers the server load. It prevents the thundering herd, and it creates a natural pacing rhythm that keeps the event from feeling chaotic. Another distributed systems failure mode is the partition problem. If a participant's network connection drops briefly, they may be temporarily partitioned from the shared state. When they reconnect, their client needs to reconcile its local state with the server state. If the reconciliation isn't handled gracefully, the participant may appear in the wrong location. They may lose their team assignment, or they may see objects in a different state than the rest of the room. For event organizers, the practical response is to design activities that are resilient to temporary disconnections. If a participant drops during a collaborative puzzle, they should be able to rejoin and resume contribution without resetting the team's progress. If a participant drops during a competitive challenge, the server should freeze their score rather than resetting it to 0. These resilience patterns require server-side logic. They can't be implemented through client-side customization alone. And they're exactly the kind of engineering detail that separates professional event design from amateur experimentation. Test at scale, test with realistic network conditions, and test the failure modes, not just the success paths. Custom environments and the no-code ceiling. Teams Immersive offers no-code customization tools. You can add images, videos, 3D models, branding elements, and ready-made experience templates. You don't need to write code. You don't need a Unity developer. You don't need to manage a separate 3D content pipeline. This is a genuine advantage for business users. It lowers the barrier to entry, it speeds up deployment, and it prevents custom code from breaking compliance or introducing security vulnerabilities. But the no-code approach also has a ceiling, and that ceiling breaks more events than any technical glitch. Here is the limitation that most organizers discover too late. Customization sessions expire 8 hours after the last join. If you spend an afternoon building a custom space and then close the editor, you have 8 hours to run your event before the customization session times out. For a single event, this is manageable. For a recurring team-building program, this is a structural problem. You can't save a custom template and reuse it across multiple events. Microsoft has flagged this as coming soon, but as of mid-2026, it isn't available. That means every recurring immersive event requires rebuilding the custom environment from scratch or settling for the out-of-the-box templates. Neither option scales. If you run quarterly team-building events, you need to budget setup time for each one. You need to document your layout decisions so you can recreate them. And you need to train multiple facilitators because the one person who built the first event may not be available 3 months later. There's also no access to the underlying physics engine. You can't modify gravity parameters. You can't adjust collision detection. You can't implement custom hand tracking interactions. The physics and interaction model is managed entirely by Microsoft. For IT and compliance teams, this is a feature. It means participants can't inject custom scripts, modify world state in unauthorized ways, or create content that violates data loss prevention policies. The environment is sandboxed, and that sandboxing protects the organization from the security risks that plague consumer metaverse platforms. For event designers who want to build elaborate gamified experiences, this is a constraint. You're customizing within Microsoft's boundaries, not building outside them. The practical takeaway is this: design your event around what Teams Immersive can do reliably. Don't promise a fully bespoke metaverse experience and then underdeliver because the platform doesn't support deep customization. Use the no-code tools for branding, layout, and media placement. Use out-of-the-box templates for speed and stability. And treat anything that requires custom physics or complex game mechanics as outside the current scope of the platform. If you need fully bespoke 3D interactions, you're not looking for Teams Immersive. You're looking for a custom game engine deployment with Azure backend services. That's a completely different budget, skill set, and risk profile. And for most enterprise team-building use cases, it's overkill. The organizations that succeed with Teams Immersive treat it as a meeting format with enhanced spatial context. The organizations that fail treat it as a blank canvas for unlimited creativity. The platform isn't a blank canvas. It's a structured environment with defined capabilities. And successful event design respects those boundaries. There's another customization constraint that event planners frequently encounter: Video and audio objects placed in the environment can't be previewed during the customization session. They only play during the live event. This means you can't test whether your welcome video starts at the correct volume, whether your background music loops smoothly, or whether your presentation recording plays without audio drift. The only way to verify media playback is to run a live test event with a small pilot group. And because customization sessions expire 8 hours after the last join, you need to run that pilot test within the same session window or rebuild the environment for the live event. This creates a practical workflow constraint. You shouldn't customize the environment on the day of the event. Customization should be completed at least 48 hours in advance. The pilot test should happen within the same 8-hour window. And any changes identified during the pilot need to be made immediately, because once the session expires, you start from scratch. For organizers who are used to the flexibility of PowerPoint, where you can adjust slides minutes before presenting, this workflow feels rigid. But 3D environments are not PowerPoint decks. They have loading times, asset compilation steps, and spatial audio initialization that can't be rushed. Respecting the platform's constraints is part of the engineering mindset. The out-of-the-box templates deserve more attention than they typically receive. Microsoft provides several ready-made environments optimized for different event types. Auditoriums for presentations, social spaces for networking, training rooms for learning, and exhibition halls for product showcases. These templates are pre-tested for performance, they have balanced spatial audio mapping, they have appropriate object density for the rendering engine, and they load faster than heavily customized environments. For first-time immersive event organizers, the best advice is to use an out-of-the-box template for your first event. Customize only the branding elements, logo placement, color scheme, and welcome messages. Leave the spatial layout, audio zones, and interaction objects unchanged. Once you have run a successful event in a standard template, you can gradually introduce custom elements in subsequent events. This incremental approach reduces the number of variables that can fail, and when something does go wrong, you know whether it's a platform issue or a customization issue. That diagnostic clarity is invaluable when you're troubleshooting with 10 minutes until showtime. Conditional access and the Quest security model. If you're deploying Quest devices for immersive events, you're entering a security landscape that most M365 admins have never navigated. Quest devices run Android under the hood, they're consumer hardware made by Meta, and they don't natively support the same conditional access policies that your Windows laptops and iPhones do. Microsoft has documented a specific security architecture for enterprise Quest deployment. It requires 3 components: Meta Horizon managed services for device enrollment and management, Microsoft Intune as the mobile device management provider, Microsoft Entra ID as the identity provider. With this stack, you can enforce device-based conditional access policies. You can require that only managed Quest devices access immersive events. You can validate device type, operating system version, and configuration before granting access. But here's the first critical limitation. App protection policies, known as MAM, are not supported on Quest devices. Only device-level conditional access policies are supported. If your organization relies on MAM to protect corporate data on mobile apps, that protection layer doesn't exist for Teams Immersive on Quest. You need to exclude the Teams Immersive app from any Android app protection policies that target it. Otherwise, the app will fail to initialize or will block sign-in. The second critical limitation is authentication. Passkey-based sign-in isn't supported on Quest. If your organization enforces phishing-resistant multi-factor authentication, Quest users will fail to sign in unless you create a specific exception. The exact error codes you will see are AADSTS50199 and AADSTS53003. AADSTS50199 indicates a sign-in failure related to conditional access. AADSTS53003 indicates that the user was blocked by conditional access policy. If a user attempts to launch Teams Immersive on an unmanaged Quest device in an organization with strict conditional access, they will hit one of these errors. The user sees a generic failure message. The help desk sees a conditional access block, and the event starts in 10 minutes. To prevent this, you have 2 policy options. Create a conditional access policy that excludes Quest devices by filtering for device attributes like model and manufacturer, or exclude the Teams Immersive app from Android app protection policies in Intune. Microsoft recommends testing sign-in before deploying anything to a live event, and they recommend managing the Quest fleet through Intune and Meta Horizon rather than allowing unmanaged consumer devices to access corporate immersive events. This isn't a corner case. If you have a hybrid workforce and you want VR presence at your team building event, you will deal with this. The organizations that handle it well are the ones that test the full sign-in flow 2 weeks before the event. They provision the Quest devices, enroll them in Intune, verify the conditional access policy, and run a test immersive session with actual users. The organizations that handle it poorly are the ones that hand a Quest to an executive 5 minutes before kickoff and hope for the best. That executive will see an error code. The help desk will scramble. And the event will start with a technical disruption that sets the wrong tone for the entire session. Security in immersive events isn't an afterthought. It's a prerequisite that determines who can even enter the room. And the time to solve it's weeks before the event, not minutes before the opening remarks. There's a third security consideration that's rarely discussed in event planning: data residency and compliance. Because immersive events inherit Teams' compliance architecture, meeting recordings, chat transcripts, and shared files are stored in the same SharePoint and OneDrive locations as standard Teams meetings. This is generally good news. It means your existing retention policies, data loss prevention rules, and e-discovery workflows apply without modification. But it also means that anything said or shared in the immersive space is subject to the same compliance scrutiny as any other Teams meeting. For team-building events that include personal sharing, icebreaker questions about family or hobbies, or informal conversations, participants may not realize that their avatar interactions are being recorded and retained according to corporate policy. The facilitator should communicate the compliance posture at the start of the event. Not in a lengthy legal disclaimer, but in a simple statement. This event is recorded and subject to our standard meeting retention policies. Please share accordingly. That transparency builds trust, and trust is the actual goal of team building. For organizations in regulated industries, there's an additional layer. If your compliance framework requires that certain meeting types be excluded from recording or transcription, you need to verify that Teams Immersive respects those same settings. The meeting options available in standard Teams, such as disabling transcription or restricting recording to organizers, should apply to immersive events as well. But you should verify this in your tenant rather than assuming it. The organizations that handle security well create a dedicated conditional access policy for immersive events. They name it clearly, they document the exceptions, they review it quarterly, and they communicate the requirements to event organizers as part of the planning checklist. The organizations that handle security poorly treat every immersive event as an ad hoc exception, and they accumulate a patchwork of undocumented policy relaxations that become impossible to audit. Designing the 60-minute immersive agenda. Now we put latency and logic together into a practical blueprint. Here is the anatomy of a high-stakes immersive team-building event that actually works. The first 5 minutes are a landing zone. No content, no instructions, no agenda slides, just arrival and avatar warm-up. Participants need time to find their bearings in 3D space. They need to test their audio. They need to figure out how to move, how to emote, and how to find other people. If you rush this phase, you lose people before the event starts. The landing zone should include obvious gathering points, a central plaza where people naturally spawn, clear visual cues pointing toward the main activity areas, and a facilitator avatar that's visibly present, not hidden in a host control panel. Minutes 5 through 15 are an icebreaker in spatial audio circles. Keep the stakes low and the interaction high. Simple prompts work best. Find someone wearing the same color avatar as you. Share one thing nobody at work knows about you. These are not elaborate games. They're social lubrication that lets participants experience spatial audio and proximity-based conversation without pressure. The icebreaker should force movement. If participants stand still and talk to the people nearest them, they don't learn how spatial audio works. Design prompts that require walking across the space, finding specific locations, or gathering in small clusters. Movement teaches the interface. And interface confidence determines whether participants engage or withdraw. Minutes 15 through 35 are the main challenge. This is where the team building happens. Use teams of 4 to 6 people. Design a collaborative puzzle or creative challenge that requires discussion, decision-making, and shared progress. Server-mediated scoring keeps it fair across latency differences, and a visible progress bar or leaderboard adds motivation without relying on reaction time speed. The facilitator should move between teams in the 3D space, not watch from a control panel. Physical presence in the space, even as an avatar, signals engagement. Participants can tell when a facilitator is present versus absent, and that presence changes their level of participation. The challenge should have multiple stages. A single 20-minute activity is too long. Break it into 3 or 4 phases with clear transitions. Each phase should introduce a new mechanic or a new piece of information. This maintains attention and prevents the mid-activity lull that kills engagement. Minutes 35 through 50 are cross-team debrief. Bring everyone back to a central auditorium or presentation zone. Use the built-in screen sharing to display results. Let teams share what they learned, and use this time to reinforce the social connections that formed during the challenge. The debrief isn't a lecture, it's a conversation. The facilitator should ask open questions. Tell me what surprised you. Tell me what you do differently. Tell me what you learned about someone on your team. These questions translate the activity into relational insight, and relational insight is the actual product of team building. The debrief should also address technical issues transparently. If some participants experienced lag or audio problems, acknowledge it, thank them for persisting through the technical difficulties, and commit to fixing those issues for the next event. That transparency builds credibility. Participants know that technical issues happen. What they resent is pretending the issues did not exist. By naming the problems and committing to solutions, the facilitator turns a potential negative into a trust-building moment. Minutes 50 through 60 are closing ritual and feedback capture. Not a lengthy speech, not a corporate pep talk. A simple closing question that everyone answers, one word to describe the experience, or a virtual selfie shared in the team's chat afterward. Then capture feedback immediately, while memory is fresh. A 2-question Microsoft form sent in the meeting chat takes 30 seconds to complete and gives you measurable data for next time. The questions should be specific, not asking how the event was in general, but asking which activity created the strongest connection with a teammate, and asking what technical issue, if any, disrupted your experience. The total runtime is 60 minutes, not 90, not 120. Immersive presence is cognitively demanding. Avatar navigation requires more mental load than passive video watching. After an hour, attention drops, social fatigue sets in, and the quality of interaction declines. End on time. Leave people wanting more rather than wishing it would end. The 60-minute runtime is based on cognitive load research. Avatar navigation requires sustained attention to spatial relationships, interface controls, and audio directionality. Participants can't multitask in immersive mode the way they do in standard video calls. There's no second monitor to check email. There's no minimize button to respond to a chat. The immersive client demands full attention. That demand is valuable for engagement, but it's exhausting for duration. After 60 minutes, avatar navigation becomes a chore rather than a novelty. Social interactions become strained rather than natural, and the quality of team-building interactions declines measurably. If you genuinely need more than 60 minutes, break the event into 2 45-minute sessions with a 15-minute break in between. The break allows participants to step away from the screen, recharge, and return with fresh attention. And the 2-session format gives you a natural midpoint for feedback collection. The agenda should also account for the facilitator's cognitive load. A facilitator in immersive mode isn't watching a gallery view and reading chat. They're navigating a 3D space, monitoring multiple team zones, responding to spatial audio conversations, and managing event transitions. This is more demanding than facilitating a standard Teams meeting. Plan for facilitator rotation if the event exceeds 45 minutes, and always have a co-facilitator who can handle technical issues while the primary facilitator maintains engagement. The pre-event engineering checklist. A great agenda means nothing if the pre-flight checks fail. Here's the checklist that separates successful events from disasters. Network audit. Confirm split tunneling is active for Teams traffic. Verify that Azure Communication Services IP ranges and ports are open in your firewall. Check that QoS markings for real-time media are applied on your network edge. And test the path from every office location that will participate. If the round-trip time is above 50 milliseconds, expect jitter problems. Run the test during peak hours, not during quiet periods. Network congestion at 9 a.m. is different from network congestion at 2 p.m. If your event is scheduled for 3 p.m., test at 3 p.m. Hardware audit. Test every device class that will join. Corporate laptops, personal Macs, any Quest devices. Run a standard Teams video call with 5 participants on each device class. If the GPU utilization is above 70% or the frame rate stutters, immersive mode will be worse. Also test on battery power, and test with the same number of background applications that participants typically run. A clean test environment isn't realistic. Test with Outlook open, with browser tabs active, with the same load that real users carry. Identity audit. Verify that Quest users can sign in before the event. Create a test conditional access policy and confirm that managed Quest devices pass and unmanaged devices fail as expected. If your organization enforces phishing-resistant MFA, create the necessary exception for Quest before the live event. Don't discover AADSTS 53003 on the day. Also verify that guest users can join. Add a test guest account, send them the immersive event link, and confirm they can enter the space. Guest access for immersive events has specific limitations, and it's better to discover them in testing than during the live session. Environment audit. Customize your space at least 48 hours before the event. Test it with a pilot group of 4 to 6 people from different network conditions. Verify that spatial audio zones work as intended. Confirm that screen sharing displays correctly in the 3D space. And accept that immersive templates can't be saved for reuse yet. If you need the same layout next quarter, document your configuration manually. Take screenshots of your layout, write down the coordinates of key objects, and save any uploaded media files in a shared location so you can re-import them later. Fallback plan. Designate a standard Teams meeting as your parachute. If more than 20% of participants can't join immersive mode, the facilitator needs authority to pivot immediately. Have the backup meeting link ready, have the facilitator script for both formats, and communicate the fallback plan to participants in the pre-event instructions so they know what to expect if immersive mode fails. The fallback isn't a failure. It's professionalism. The organizations that plan for failure are the ones that never need to use the fallback. The organizations that ignore failure are the ones that end up apologizing. There's one more checklist item that experienced organizers add: participant communication. Send a pre-event email 72 hours before the event. Include the hardware requirements, include the platform limitations, include the test link, and include a clear statement about unsupported devices. If participants know in advance that mobile and web are not supported, they will find alternatives. If they discover this when they try to join, they will blame the organizer. The pre-event communication should also set expectations about the event format. Tell participants that they will be in a 3D space. Tell them that they need a headset or speakers for spatial audio, and tell them that the event is interactive, not a presentation. Setting these expectations reduces anxiety. Participants who know what to expect are more likely to engage. Participants who are surprised by the format are more likely to withdraw. The organizations that run smooth immersive events are not lucky. They're prepared, and preparation is engineering, not improvisation. There's one final checklist item that separates experienced organizers from first-timers, and that's documentation. After every immersive event, write a brief after-action report, 1 page, not a formal document, just a summary of what worked, what failed, and what to change next time. Include the participant count, include the device mix, include the network issues encountered, include the activity ratings from the post-event survey, and include any unexpected platform behavior. That document becomes the institutional memory of your immersive event program. It prevents you from making the same mistake twice. It helps new organizers learn from previous events. And it provides evidence when you need to justify infrastructure investments to leadership. The after-action report should be stored in a shared location, a SharePoint site, a Teams channel, or a OneNote notebook, somewhere that the next event organizer can find it without asking. Over time, these reports accumulate into a playbook, and that playbook is the most valuable asset your organization can build around immersive collaboration. Post-event analytics and the ROI question. After the event, the work isn't done. You need to determine whether the event was worth the investment. Teams Immersive provides some built-in signals. Attendance duration, chat activity, selfie sharing in the 3D space, breakout participation if you use separate zones. But the platform doesn't provide granular spatial analytics. There are no heat maps of where avatars spent the most time. There's no eye tracking data. There's no detailed telemetry on which interactions were most engaging. For most organizations, that level of analytics is neither available nor necessary. What you need is a comparison framework. Compare the engagement metrics from your immersive event against your last flat grid video event. Check whether more people stayed for the full duration. Check whether chat activity increased. And check whether participants reported higher satisfaction in the post-event survey. Use Power Automate to capture post-event survey data from Microsoft Forms. Trigger the flow when the event ends. Send the survey link in the Teams chat. And aggregate responses into a SharePoint list or Dataverse table. From there, you can build a Power BI dashboard that tracks event satisfaction over time. You can correlate immersive event attendance with broader signals from Viva Insights, and you can build a business case for recurring investment in spatial collaboration. The honest ROI framework is simple. If your team-building event created stronger cross-functional relationships than a standard video call, it delivered value. If participants report higher energy and lower fatigue than your typical virtual meeting, it delivered value. And if the event became a reference point that people talk about weeks later, it delivered value. Those are soft metrics. But team building is a soft investment. The goal isn't a spreadsheet. The goal is trust. And trust is measurable in retention, collaboration frequency, and qualitative feedback. The organizations that treat post-event measurement seriously improve their events every quarter. They identify which activities worked, which technical issues recurred, and which participants were excluded. They iterate, and over time they build an immersive event capability that's genuinely better than their traditional meeting format. The organizations that skip measurement assume the event worked because nobody complained. That isn't evidence of success, that's evidence of silence. And silence often means disengagement, not satisfaction. To build a meaningful measurement framework, start with 3 baseline metrics from your last traditional video event: average attendance duration, chat messages per participant, and post-event survey score. Compare these same metrics for your immersive event. If attendance duration increases by 10% or more, the immersive format is holding attention better than video. If chat messages per participant decrease, that may indicate that spatial audio is successfully replacing text chat for side conversations. And if the survey score increases, participants are finding value in the experience. But don't stop at comparison. Add immersive specific metrics: avatar movement distance, time spent in interactive zones versus passive zones, and selfie sharing rate. These metrics reveal whether participants are actively engaging with the space or passively observing. Active movement in immersive environments correlates with perceived presence. Participants who move through the space, visit multiple zones, and interact with objects report higher satisfaction than those who stay in one location. This makes intuitive sense. Movement requires attention. Attention creates engagement, and engagement creates memory. You can approximate movement metrics by observing the event as a facilitator. Note which zones are crowded and which are empty. Note which activities generate spontaneous conversation and which generate silence. And note where participants cluster after the formal agenda ends. Those informal clusters are the most valuable signal of all. They indicate that participants feel socially comfortable in the space. For a more quantitative approach, Power Automate can capture structured data from post-event surveys. Ask participants to rate 3 specific elements: the spatial audio experience, the ease of navigation, and the quality of team interaction. These 3 questions target the core value proposition of immersive events. They reveal whether the technical infrastructure supported the social outcome. Over time, aggregate these scores in Power BI. Create a dashboard that tracks event satisfaction by month, by department, and by event type. identify which activities consistently score highest, and identify which technical issues recur most frequently. That longitudinal view transforms individual events into an organizational capability. Leadership can see whether immersive events are improving or degrading over time. They can justify budget allocations based on trend data rather than anecdote, and they can identify when the platform itself has improved enough to justify deeper investment. Let us look at how to build a basic measurement dashboard in Power BI. Start with a simple data model. One table for events, columns for event date, participant count, event type, and facilitator name. One table for survey responses, columns for participant ID, overall rating, audio quality rating, navigation ease rating, and favorite activity. One table for technical issues, columns for issue type, severity, participant count affected, and resolution status. Link these tables on event ID and build 3 simple visualizations. A line chart showing average satisfaction score over time, a bar chart showing technical issue frequency by type, and a scatter plot showing participant count against satisfaction score. The scatter plot is particularly revealing. If satisfaction decreases as participant count increases, you have a scale problem. Your activities or infrastructure are not keeping up with larger groups. If satisfaction stays flat regardless of participant count, your event design is robust. And if satisfaction increases with participant count, you have found a format that benefits from larger crowds. That data-driven insight changes how you plan future events. Instead of blindly increasing participant counts because the platform supports larger events, you optimize for the size that delivers the best experience. The other valuable visualization is a geographic heat map. Plot participant satisfaction by region. If participants in one office consistently rate events lower, investigate their network path. If participants on Quest devices rate audio quality lower, investigate the spatial audio rendering differences between Quest and desktop. And if guest users consistently report navigation difficulties, improve the pre-event instructions for external participants. These visualizations don't require advanced Power BI skills. They're basic charts built from structured survey data, but they provide insights that no amount of verbal feedback can match. The measurement framework should also include a quarterly review cycle. Every 3 months, gather the event organizers, IT support team, and a sample of participants. Review the dashboard trends, identify the top 3 issues, and assign owners to resolve them before the next quarter's events. That review cycle creates accountability. It prevents issues from persisting across multiple events. And it demonstrates to leadership that the immersive event program is actively managed rather than passively executed. There's also a cost avoidance metric that leadership cares about. A failed immersive event wastes more than the event budget. It wastes the time of every participant. If 200 people attend a 60-minute event that fails, that's 200 person-hours of lost productivity. At loaded cost rates, that failure can cost more than the event infrastructure itself. Preparation prevents that waste. A thorough pre-event engineering checklist takes 4 to 6 hours to complete. That's a tiny investment compared to the cost of a failed event. And the checklist becomes faster to execute with each iteration as the organization builds institutional knowledge. The organizations that treat immersive events as a strategic capability rather than an occasional experiment also see compounding returns. Their events get better over time. Their technical issues decrease, their participant satisfaction increases, and their cost per successful engagement drops. That's the metric that ultimately matters. Not whether immersive events are possible, but whether they're consistently effective at a sustainable cost. The old model versus the new model. The old model was to buy a metaverse product, customize a world, and hope people showed up and felt engaged. The new model is to engineer a team's native experience where latency, logic, and limitation are treated as design constraints rather than surprises. Microsoft Mesh isn't a product anymore. It's a feature inside Teams, and that changes every assumption about licensing, network architecture, security, and what custom actually means. If you're still thinking about immersive collaboration as a visual effect, your next event is already at risk. But if you treat it as systems engineering, you can build team experiences that actually deliver presence. Immersion isn't a visual effect, it's a systems engineering outcome. The old model treated immersive collaboration as a product purchase. You bought the licenses, you deployed the app, you customized the environment, and you hoped the technology would deliver the engagement. That model failed because it treated immersion as a feature rather than a system. It assumed that visual customization equals experience design. It assumed that network bandwidth is the only infrastructure concern, and it assumed that security and compliance would adapt automatically to a new platform. None of those assumptions were true, and the organizations that operated under them built events that looked impressive in screenshots but felt hollow to the people who attended them. The new model treats immersive collaboration as an engineering discipline. It starts with infrastructure audit, network paths, hardware profiles, security policies, and compliance boundaries. It continues with activity design that respects the platform's constraints. No reaction time competitions across unequal latency profiles, no complex custom physics that the platform can't support, and no promises of fully bespoke experiences when the toolset is no code. It ends with measurement and iteration, post-event surveys, technical issue tracking, longitudinal engagement metrics, and a feedback loop that makes each event better than the last. This isn't a technology problem, it's a design problem, and the organizations that solve it are the ones that treat every immersive event as a systems integration challenge rather than a content creation challenge. Microsoft Mesh isn't a product anymore, it's a feature inside Teams, and that changes every assumption about licensing, network architecture, security, and what custom actually means. If you're still thinking about immersive collaboration as a visual effect, your next event is already at risk. But if you treat it as systems engineering, you can build team experiences that actually deliver presence. The difference between a ghost town and a gathering isn't the quality of the 3D models, it's the quality of the preparation, and preparation is engineering. As you plan your next immersive event, remember the two pillars, latency and logic. Latency is the real-time performance that makes presence possible. Logic is the orchestration that makes presence meaningful. When latency fails, the space feels broken. When logic fails, the space feels empty. And when both work together, the space feels alive. That aliveness isn't something you can buy, it's something you build. One network audit at a time, one hardware check at a time, one activity test at a time, and one after-action report at a time. The organizations that build this capability are not chasing the metaverse hype. They're solving a practical problem. They need to create genuine human connection when their teams are distributed across cities, countries, and continents. Teams Immersive is one answer to that problem, but it's only an answer if you engineer it correctly. If this changed how you think about hybrid events, follow me on LinkedIn and leave a review if you want more M365 architecture deep dives like this.